So now we're going to talk about the region under an f of x, and that's going to be the plate that we're wanting to find the center of mass on. Just like I was saying, if I take this here, I want to find where it is that I can put the point so it balances. Okay, so let me just get this picture going. So I want the centroid, the center of mass, so the x bar, y bar, bounded by these functions. So we know we've got the root x, x equals 4, y equals 0. So this is the area that's bounded. So to find the x bar and y bar, I need to find the m sub y divided by m and the m sub x divided by m. So the m is going to be the mass, how much it is. And so that's going to be the quantity of the area. So we can figure that out, right? So let's go find the m for our example problem here. So it's going to just be 0 to 4 of root x dx. So we know that's 2/3 x to the 3/2 between 0 and 4. Let me just continue it here. So then I have 4 to the 3/2. And you know the square root of 4 is 2, cubed is 8, so I get 16 over 3. So that's my m value. So that's going to go in the denominator. So let's go find the m sub y. So m sub y is the moment about the x-axis, and let me give you a little bit of an idea of why this formula is as it is, not a full-on proof, but I want to find the product of the mass times the distance it is from the y-axis. So if I'm trying to find this x bar, right, I want to find the mass, which would be the integral of the function, right, because we've got that, times the distance it is away from the y-axis, which is going to be an x value. So that's why I just take x times the function and integrate it between 0 and 4. So you know that you would need to rewrite this as x to the 3/2. Then you'd get 2/5 x to the 5/2 between 0 and 4. So 2/5, 4 to the 5/2. That's 2 to the 5th power, so that's 32 times 2, so 64 over 5. So that's the m sub y. So that means I can now find out what the x bar is. X bar is 64/5 divided by my m, 16/3. So 64/5 times 3 over 16, cancel 8. So I'd get 8 times 3 over 5 times 2. I guess I can cancel. Oh, I should have canceled the 16. Oh, well. So now I have it 12 over 5. So that's my x bar. Okay, so now let's go look at what the m sub x is going to be. So m sub x up here. So that's going to be the product of the mass times the distance it is away from the x-axis. And so that's going to be here. And we're going to want to find that center. And so I'm going to take half of f of x. So if this was the whole region, right, all the way up to the f of x, I want to go half of that. So that's where that comes from. So the m sub x turns out to be 1/2 the function squared. And then from 0 to 4. So this just turns into x. So I get 1/4 x squared over 2. And then between 0 and 4, so I get 4. So that's the m sub x. So that means that my y bar is going to be 4 divided by 16/3, or 4 times. So I end up getting 3/4. So my x bar, y bar, there's my y bar, and there's my x bar.